Hi, this is the fourth video in the series where we're looking at the November 2017 paper, and it's paper 3, calculator paper. In the previous video we completed through to question number 17, so we're going to start here from question number 18 onwards. I would say these final few questions, 18 is not too bad, but the other ones are quite tricky, so please do stop the video, have a go at each of these questions and then compare your solutions. Okay, so the first one is it's a speed time graph for a train, and it actually tells us that we need to work out an estimate for the distance the train travelled for the first 20 seconds using 4 strips of equal width. So really it's just a case of working out the areas of each of these strips, okay, 4 equal strips. Now really the way to do that would be to use the trapezium formula for these three, and also a triangle then for area A. So we've got area A is going to be a half base times height. Okay, I would do it something like that. So I'm going to get a half, and then the base is going to be 5 and the height is going to be, in this particular case, 2. Just be very careful about this scale here. Okay, this actual point here is going to be a height of 2, not a height of 4. Okay, so just be really careful with that. That's going to give you A is going to be 5. Okay, let's look then at B. Now B is a trapezium, so I'm going to use the trapezium formula, which is going to be a half A plus B times h. Okay, again put this information in and you should be absolutely fine. It's 2 plus 5 and height in this particular case of 5, and that's going to give you 17.5 for B. Okay, C we're going to do exactly the same, and again we're going to use the trapezium formula, half A plus B times h. Okay, plug the information in. I'm going to get a half 5 plus 10, and that's going to be multiplied by 5 again, so that's going to give you 37.5. okay, and then D is the final one. Again, a half A plus B times h. I'm sorry my writing is quite small on this particular one, but hopefully it'll give you some idea, and that's going to be a half 10 plus 18 times h is 5. Okay, pop that in your calculator, that's going to give you 70. So if you add up each of these, it's going to give you a total distance then, total of 130 meters. Okay, all righty, hope that's all right for you. And then part B of the question, it says, is your answer to part A an underestimate or an overestimate the actual distance? Okay, well it's actually an overestimate, okay, because what I've done, and I'll draw you a quick diagram, is that the area is greater than the curve. Okay, and again apologies for the awful writing here, but basically what I'm getting at is that if we've got a curve like that, okay, I'm actually working out this, okay, as a trapezium area. Okay, so hopefully that's all right for you. You might want to just elaborate on that a little bit, but it is only a 1 marker, so it's kind of, you're making your case really for either an overestimate or an underestimate. Okay, so question number 19, and this is where it just gets a little bit trickier. Okay, prove algebraically that the straight line with the equation that is a tangent to the circle. Okay, so basically what we're saying is the circle itself is x squared plus y squared equals 20. Okay, well that value of 20 is actually r squared. Okay, so it's a value of somewhere between 4, which would be if it was 16, and 5 if it was 25. So let's say it's got a radius of 4.5. Okay, so if I drew that, I'm not going to draw a fantastically elaborate drawing, but I've got a circle. Okay, and then what we're saying is actually we've got a tangent to that circle. Okay, now the only way it's going to be a tangent is if this has one solution for x and one solution for y. If it was actually crossing through, then it would have two solutions. Okay, but it must be a tangent if it's got one solution. Okay, so I would put that somewhere on your text. So tangent if one solution. Okay, and then really it's just a case of using substitution in this particular case to figure out the value of x and the value of y. So the first thing is that I've got this value of the straight line, which is x minus 2y equals 10. Well, I don't really want minuses floating around. So what I'm going to do is I'm actually going to make that a positive value, okay, if I can. So what I would say is, well, actually, I'm going to take this value of 2y and I'm going to take it to the other side. So I'm going to get x equals 10 plus 2y, okay? And then I'm going to get my value of y. So if I divide through by 2, I'm going to get, effectively, I'm going to get a half x minus 5 equals y, okay? Because if I bring this 10 over here, I'm going to get x minus 10, and that's going to equal 2y. Divide through by 2, and that's going to give me a half x minus 5 equals y. Okay, so I've got that value of y. I've also got my value of x. Now what I'm going to do is I'm going to take this value of x and I'm going to plug it straight into this equation. Now the reason I've done this will come a little bit clearer later on, okay, but at least it's going to give me some ability now to be able to calculate my values, okay. So let's have a look then at substituting this value of x straight into there, or straight into this equation at the top. So I know that x squared plus y squared equals 20, okay. So rather than writing x, I'm going to write 10 plus 2y, and that's going to be squared plus y squared equals 20. Now I can then just expand this out and solve for y. So I'm going to get 10 plus 2y multiplied by 10 plus 2y again plus y squared equals 20. Okay, if I multiply this out here, I'm going to get, let's just move this up a little bit so you can see, I'm going to get 10 times 10 is 100, and it's going to be plus 20y plus 20y is plus 40y plus 4y squared plus y squared equals 20. Now actually it's giving me some level of comfort, if that's the right word for this at this particular point, because I've got a whole bunch of numbers there that are all going to be divisible by 5, okay, I think. Alright, so let's just gather up the terms together, and then also we need to make it equal to 0. So the first thing I'm going to do is I've got 4y squared plus y squared is going to give me 5y squared plus 40y. That's fine, both of those divisible through, that's perfect, no problem. And then I've got 100 on this side, but don't forget I need to make it equal to 0 in order to factorise it. So it's going to be minus 20 is going to be plus 80, and that's going to equal 0. If I divide through now by 5, I'm going to get y squared plus 8y plus 16 equals 0. Okay, now if you've got a little bit of experience with factorising equations, you might recognise that one, that actually I can factorise that for y plus 4 multiplied by y plus 4 equals 0. So actually it's looking good for my single values, because I know that y plus 4 means that the value of y is going to be equal to minus 4. Okay, that would be my value of y. And then really it's a case of saying, well, actually I can now take that information and plug it into this equation at the top in order to work out my value of x. I'm just realising now I didn't actually need that, but I'm going to work out my value of x using this particular formula. So I've got x equals 10 plus 2y. So that's going to equal 10 plus 2 times minus 4. Well, 2 times minus 4 is going to be 8. So therefore, or minus 8 rather, I've got 10 minus 8, so therefore x equals 2. And that will give me the solution to this particular question, because x equals 2, y equals -4, and there is one solution. And as I mentioned before, right at the very beginning, that because there is only one solution, then it must be the tangent. Okay, I hope that's all right for you. We're on to about 10 minutes into this video, so I'm going to move on to question number 20, and this is one of those questions where it's a proof question, but it's one of those questions that comes up fairly frequently, so it is worthwhile getting to grips with this particular proof. Okay, so what we've got is we're going to prove that ACB, which is ACB, is actually 90 degrees. And then it says you must not use any circle theorems in your proof. So the first thing I'm going to say is, well, okay, that's fine. I'm going to divide this up into two isosceles triangles, because if I do that, I know that they must be isosceles because each of the lines that I've marked there is a radius. Okay, so let's have a look then. I'm going to say that angle AOC equals x. Okay, so that's x degrees. Okay, so therefore angle ACO, okay, which is this top angle here. Now remember, because it's an isosceles triangle, this angle and this angle must be the same. It's going to be the same as 180 minus x divided by 2, okay, because they're both the same. So it's going to be 90 minus a half of x. Okay, hopefully that's all right for you. And we're going to do exactly the same with the other triangle, but this time we're going to say that this is equal to y. And again, I'm going to look for that angle at the top there. Okay, so what I would put is something along the lines of angle BOC equals y, okay, which is the one that I just put in. Okay, therefore, angle OCB is going to be exactly the same. It's going to be 180 minus y divided by 2. So it's going to be 90 minus a half of y. So therefore what we've got is an expression for these two angles at the top, one for x and one for y. Okay, and then it's really just a case of putting that into the triangle of ACB in order to make it clear to the examiner, and then work it through to get that value of 90 degrees. So let's look now at triangle ACB. So let's draw that. Okay, so this is the big triangle, and we're trying to prove that this is 90 degrees. That's ACB. Now remember, this top is made up of two angles, so angle ACB is going to equal to 90 minus a half x, which is this first value here, plus 90 minus a half of y. Okay, so once I've kind of gathered up my like terms here, what I'm going to get is 90 plus 90 is 180, and I've got minus a half y minus a half x minus a half y is minus a half x minus a half y. Okay, now I can leave it like that if I want to, but actually what I'm going to do is just put this into brackets, and I'm going to get 180 minus, and remember that's going to be a half x plus a half y. Okay, so this bit here, it's really important to me, because if I now look at AOB, which if you remember is actually this straight line here, I've got value of x and value of y. So what I'm saying is 180 degrees equals x plus y in order to make that straight line. Okay, so let's just have a look at that at the very bottom. So let's look at AOB. Well, AOB is this line, isn't it? This part of it is x, part of it is y. So therefore that I can say 180 degrees equals x plus y. But what it also means is that if I divide through by 2, I can say that 90 degrees equals a half x plus a half y. Okay, And then that bit of it can be plugged straight into here. Okay, because a half x plus a half y is going to go into here, and what we're saying is that must be then 180 minus 90 degrees. Okay, so angle ACB is equal to 180 minus this value that goes in here. So angle ACB equals 180 minus 90 degrees, so therefore it must be 90 degrees. Okay, quite a tough one at that particular point, so very difficult to kind of get your head around, but it is worthwhile doing because they do crop up a lot on these types of questions. Okay, let's have a look then at the final question on this particular exam, which is question number 21. So in question number 21, we're working with vectors. So in a vector, we've got essentially forces. So what we're saying is that OA is equal to A, okay? And we're also being told that OB, which is this whole area here, is equal to B. Okay, I'm just going to write that down, something like that, because that M value, which is the midpoint, means that this is going to be a half B, and this is going to be a half B. Okay, now if you've not done any vector questions, it really is worthwhile having a go at these, making sure that you're up to speed with working through vector questions. These are quite tricky to do. Okay, and there are some playlists on the channel if you want to have a look at any of these similar sorts of questions. Okay, so we've got AP equals this scalar, this factor of AB, where K is a scalar quantity. It just means a multiple, a linear multiple. Okay, then it says, given that MPN is a straight line, find the value of K. All right, so this is going to be just a little bit challenging, but let's have a look and see how we get on. All right, so hopefully you'll be able to follow this through. So what I'm saying is that if I want to work out AB, so vector AB, okay, so vector AB is going to be equal to vector AO plus vector OB. Okay, right, that's fine. So let's have a look at that. Well, that means then that vector AB is going to be equal to minus A plus B. Okay, hopefully that's all right for you. I'm actually going to change that to B minus A just because it's a little bit easier. All right, now, based on the information that we've got, we're saying that AP is a scalar quantity. It's a factor, a multiple of AB. So I can absolutely say then that AP is going to be equal to K multiplied by B minus A. Okay, so that's my first kind of bit of information that I'm going to need for this particular question. Right, let's have a look then at MN. Okay, so if I want to know MN, okay, then the only way of doing that is to go MO plus ON. Okay, so let's feed that information in. Well, remember that MO is going to be half of B, or it's going to be minus half of B because it's going in the other direction. And also remember that AN, okay, so AN is two lots of AO, so this means that this will be 2A. All right, this one at the very top here. Okay, hopefully you can see that. So let's have a look then at plugging this bit of information in. So MO is going to be minus a half of B, and then ON is going to be plus 3A. Okay, so just for the sake of, I don't like negatives right at the very beginning, I'm going to have MN is 3A minus a half of B. Okay, hopefully that's all right for you. Okay, so the other one then is I need to look at NP. Now, the reason I want to look at NP is because we've got this MPN is a straight line, find the value of K. Well, NP is going to involve AP. Okay, so NP is going to involve AP because I can go that way plus that way. And once I start getting involved in this, hopefully then it'll give me some clue as to how I can solve this particular question. Okay, so my next little bit then is going to be NP. Okay, well NP is going to be valued at NA, okay, plus AP. Now remember that before we know what AP is, or at least we've got that bit in place. NA is going to be equal to minus 2A, and NP is going to be KB times minus A. All right, so we've got now the component parts to be able to solve this particular question. Okay, so I hope we have anyway, because it tells us that NPN is a straight line, find the value of k. Well, if it's a straight line, what we can say is that vector NP multiplied by some coefficient equals NM. Okay? All right, so let's now have a look at NP. Well, we've worked it out, it's that. So I'm going to say that's going to be the same as going x times minus 2a plus k times b minus a. Okay, and that's going to be equal to minus 3a plus a half of b. Okay, so let's expand that out a little bit. So I'm going to get minus 2ax plus, this is kb, but multiplied by x is going to be x b k, okay, and then I'm going to have the same again. I've got k times minus a is minus ak times x is going to be minus kax, and that equals minus 3a plus a half of b. All right, this is where it does get tricky, because now we need to use this particular technique, which is called matching coefficients. All right, now if you've not come across this technique before, it's something that seems to be emerging a little bit with GCSE questions, particularly towards the very end. Okay, so what I'm going to do is I'm going to rewrite this bit of information on the back of the sheet, and then hopefully you'll be able to kind of figure out what it is I'm doing there. Okay, so the first thing I'm going to do is I'm going to just turn this over. All right, now what we've got then is we've got minus 2ax plus kbx minus kax equals minus 3a plus a half of b. Okay, now very, very tricky to kind of work through, but let's have a look at splitting the coefficient of a's. Okay, so if we split a's, we've got this one, and this one. Okay, so if I look at that, I can take a out of both of these terms, and I can write that as a minus 2x, and then I've got minus kx, and that equals minus 3a. All right, so if I now divide through, because both sides have got a, it means I can divide through by a, so I can actually lose the a bit of it, and I can get minus 2x minus kx equals minus 3. Okay, so that's my first sort of bit of information. The next bit of information is I'm going to split the b coefficients. Okay, so if I split b's, okay, then I'm going to get b times kx equals a half of b. Okay, I hope you're following this. It really is quite a tricky question, particularly for a GCSE. Okay, all right, so because I've got b's on both sides, again, I can lose them, and I'm going to get kx equals a half. Okay, so if that is the case, if kx equals a half, I can just by dividing through by k, I can say that x equals a half k. All right, now I've got my value of x and I've got this value up here, so I can substitute for a half k into this equation at the top. Okay, so I'm going to substitute into 1. Okay, now if I substitute into 1, I'm going to write that as minus 2, and rather than writing x, I'm going to write 1 over 2k. Okay, and then I've got k minus k, and rather than writing x, I'm going to write 1 over 2k. Okay, and that equals minus 3. All right, so minus 2 times a half is going to be minus 1, so that's going to be minus 1 over k. And then I've got minus k times a half of k, well that's going to be minus a half, and that equals minus 3. Okay, right, so we're sort of getting there. We're on the final stretch now. Now the problem we've got here is we've got too many negatives knocking around, so I'm going to divide both sides through by a negative. Okay, that means then if I divide by a negative, I'm going to get 1 over k plus a half equals 3. Okay, so if I now take that half over to the other side, I'm going to get, I'm going to get 1 over k equals a half plus a half. And rather than writing 3, I'm going to write that as going to be 6 over 2. Then I'm going to take this half over. So 1 over k equals 5 over 2. Okay, so this is the inverse of the value of k. So therefore, after all this time, k equals 2 over 5. All right, that was a very, very difficult question to follow. Hopefully it's been okay for you. I haven't seen too many questions like this at all. But if you do have any questions, please do leave a message below in the comment and I will try to respond to you. Maybe have a look back through this particular part of the question and hopefully that will have been useful. That's the end of this particular playlist on the November 2017 higher paper. I hope it's been useful to you and I look forward to seeing you inside the next video.